We have done resistance in the previous class and we have seen what is resistance and how does conductor offer resistance. Now, we will study what are the factors on which resistance of a conductor depends. Now, see affecting factors of resistance. Now, see first one is resistance is directly proportional to length of the conductor. L we have taken here, L is length of conductor. Now, see if you have taken two conductors of the same material, same area of cross section and length is different. Suppose this is conductor 1 having length L, there is another conductor which has got length 2L and area of cross section material remains same. This is named as conductor 2. So, out of these two conductors 1 and 2, this conductor will offer greater resistance because its length is double that of this. So, resistance is directly proportional to length. It means if you have got an electrical circuit, connect first this conductor in between and measure the current, you will be getting more current, and if you are putting this conductor in between and measuring the current across this, you will be getting lesser current here because the resistance is more. Now, see another factor here, resistance is inversely proportional to A. A stands for area of cross section, So, here resistance is inversely proportional to area of cross section. If area of cross section is large, resistance is less. If area of cross section is less, resistance is large. If you have taken like this conductor, one conductor is of the two conductors of the same length having different area of cross section. See, this is A1 area of cross section, this is A2. A2 is greater than A1, both are of the same material having the same length, then we can say conductor this 2 and this is the conductor 1. So, conductor 2 offer less resistance because area of cross section is more. So, there is third factor also. Third factor is, we can write here, resistance increases on increasing temperature. So, when the temperature of conductor is increased, resistance is increased. Fourth one is also here, resistance depends on nature of the material. It means here just you can write here nature of the material. See, nature of material means here the different materials offer different resistances. So, here if you have taken like any good conductor or any poor conductor, good conductor will offer lesser resistance and poor conductor will offer very high resistance. So, these are the four factors on which resistance of a conductor depends. So, we can do a lot of things, a lot of questions related to this concept, and now we can take one more concept related to this, that is called resistivity. See here, in resistivity, as we know, R is proportional to L, R is inversely proportional to area. We can combine these two, we will be getting R is proportional to L by A, and when we remove this proportionality symbol, we can put a constant L upon A. This constant rho, it is actually pronounced as rho, and this rho is known as, rho is called resistivity or specific resistance of material. So, see here, this resistivity, that means rho, is the characteristics property of the material. So, just by knowing the resistivity of the material, we can classify the materials in the three parts. One is conductors, have got the very low resistivity. Another one is alloys, which has got greater resistivity than the conductor, and there are the third one is insulators, which have got very high resistivity. And we can see all these classification on the table given in the book, right, or the table given here, and see here there are the three parts: conductor, alloys and insulators. The resistivities are given here, and easily you can categorize which one is the better conductor, which one is the poor conductor.